start taking a look at our bell work up here. We're graphing one of these piecewise functions. It has two different rules for us. So we're gonna have two different little segments. Again, if you wanna do this with colors, I've got the colored pencils out. Because we have to do two different segments. We're gonna do our y equals 1/2. I'll do this one in blue. So that equation will be our y equals 1/2 x. But we only pick x's that are smaller than or equal to 0. And we need to do our y equals 3 minus x, but only when our x's are bigger than 0. So we're going to have two different pieces that we do. And on these piecewise defined functions like this, it's not the only option, but I think it's the easiest one is to just make a table and get a couple of points. So for our blue one here, we're going to pick some x's and substitute them in to find y values. We can plot them up. We have to have our end piece here. So we have to have an x of 0. I need to know what's happening right there. Are we going to have a closed in dot or an open circle on the blue line? We're going to have a closed circle or an open circle. Closed. Because we have the equals to, just like we would do that as a solid line if it was a whole equation thing, this is going to be a closed circle, which I will usually either draw a closed circle or I will write closed next to it because, again, I have a tendency to forget something by the time I get over to the picture. It's gone. And then for the blue one, I need some x's that are smaller than 0. So what are some numbers smaller than 0? Because we need to follow this rule when we're picking our x's. What are some x's that are less than 0? -1. You could do -2, -3, -4. As many as you want. That'll give us enough to see what's going on this line. I could keep going this way. I cannot have any higher than 0 because my x's have to be less than 0. So when we substitute these x values into this expression here, our 1/2 x, well, 1/2 times 0 is 0. I love when they're very sturdy. It makes it so nice. I knock stuff over all the time. I love a sturdy water bottle. Then we have, if our, I'm good at words. If we have our 1/2 times our -1, we're going to have our -1/2. If I have 1/2 times -2, that's when we get a -1. So we have some points here, and I could just plot this portion of the line up right as it sits. I know at 0, 0, we're going to have a closed dot, a filled-in circle. I know that at -1, we're going to be at -1/2. And I know at -2, we're going to be at -1. And we can fill in points that way. We can also look at this and go, hey, wait a second. I see some points that are nice and tidy. I could also use my slope of 1/2, rise over run, and go, well, I don't want to go up and to the right, but I can go down and to the left. So you can use the points and the slopes to get there. You don't have to do the whole table. There's lots of ways through it. But either way, we should wind up with a piece that looks kind of like this. And it keeps going to the left. There's only an arrow on the left side on this blue piece. Same vibe for the y's. We're going to pick our x's, find our y's, plot up the points. We have to start at this end piece, so we're going to start with x equals 0. For this one, are we going to have an open circle or a closed circle on our 0? Is it open or closed? Look right here. Yes, dear. Open. Because we don't have that equals to, we're going to have an open circle. So you can either do it like that, or you can write the word open. I just mark it down because it makes my brain stay better. If you can keep track of it, great. Make sure we get those correct. And then we pick our x's bigger. We could do 1. We could do 2. We could do 3. We could do 4. Whatever pieces we want. We know numbers bigger than 0. Again, put those through your expression. 3 minus x. Find your y values. I'll give you 10 seconds to do that. Find your y values. Because I know half of us just sit here and stare at this and watch me do it. Half is being generous. Find your y values and plot them up. Because I'm just going to make those pop in here. Because the other piece, our pink piece, should look, it would stop freezing, there we go, should look like that. So it should look like that. Questions on that? So just as a reminder, the bell work is not a lovely pretty picture on the board until I start to talk. Is what you do when you come in and you get settled and your brain gets booted up and back into math mode. It has reasons. So when I stand up here and I just see on 18 faces, because the vacant stares in the vague direction of the board. There are more of those than actual eyeballs. Okay, so I know it's early. I know I'm a lot for 7 o'clock in the morning. We gotta work with what we got. Okay, so I want us to look on page 7 in the notes packet. We're gonna practice one more time identifying the pieces in a piecewise function. And then we're gonna look at our first big function of the year. So put our page number up here. We are on page 7. This one is number 2. And we're trying to identify the pieces in this piecewise function. It has different pieces. So we know it's going to be a piecewise function because I have a separate chunk here, I have a separate chunk here, and I have a separate chunk here. So we have 3 pieces. They are not just horizontal lines, so we are not stepwise. So it's got to be piecewise. So when we're looking at our equations over here, I know we actually don't know super much about an equation for x squared. On these instructions here, whenever we have these kinds of function rules, it will pretty much always go from left to right. It should always go from left to right. If you're writing your own, I can tolerate things being shuffled. But if we give them to you, the first one, the one on the top, will always be the leftmost piece. So this is the piece, or the equation, or the graph for x squared. So if this is for when y equals x squared, what x values do we get to use? What's our rule for our x's? Our x's need to be what? What's the biggest my x's can be for the pink piece? 1. The highest my x's go on this pink piece is 1. Can they equal 1? Do we have a closed circle or an open circle? Closed circle. So we know it can equal. And we know that 1 is our biggest, so my x's have to be less than or equal to 1. Closed circle here means we are going to include our equals to. And this goes all the way left. Then let's look at this next piece here. I'm going to do it on green. This one we gave you absolutely nothing for it. We have to do everything. We have to figure out what our y equals, and we have to figure out what our x's are stuck between. So what does our y equal on this? What's going to go in this spot? What's the equation for that line? How do we write the equation for a straight sideways line? Because that's what that is. If I take this and finish it out the rest of the way. This is just a horizontal line. Right here. How do I write the equation for a horizontal line? Or for this horizontal line? Is it an x equals or a y equals? Is it x equals or y equals? Y. Always going to be y. Remember this guy? Y and this guy. Y equals. In piecewise functions, you're only going to have functions. Vertical lines are not functions. They fail the vertical line test because they are the vertical line test. Horizontal lines, totally fine. Vertical lines, not going to be in piecewise functions. So it's always going to be a y equals. What does y equals right here? 3. It's stuck on 3. It can't go up to 4. It can't go down to 2. It's not changing. It's stuck. It goes the whole way across. It's stuck on 3. So if we have a horizontal line, it's just the number where it is. So my f of x, my y, is going to equal 3. What is going to be true about my x's? What do we know about our x's for that piece? What does x need to be bigger than? 1. Yep. What does x need to be smaller than? I think I heard it, but it was even quieter than the 1. If x needs to be bigger than 1, what else does it need to be for that little piece? Smaller than something, because it's stuck on both sides. I heard it. It got started, but it wasn't there super confidently. Smaller than 2. Got to be bigger than 1, smaller than 2. Can it equal to 1? Can it equal to 2? Yes. So that one gets an equals to. One last piece on this one. So that's going to be our, this guy, which they've told us is 1x. Awesome. We've written the equation. We know the slope on it. Going up 1 over 1. Cool, cool. What do we know about our x's for this one? Say it louder. Open circle. So are we going to have an equals to or a not equals to? A not equals to. Does x, and let's say it's going to the right over here, so we know x needs to be bigger because we've got this right arrow. X needs to be bigger than what? 2. Because it's going off that way. X needs to be bigger than 2. 3, 4, 7, 12, 500, 8,943,842.7. Anything over here? Okay. So when we're looking at these piecewise functions, if we're needing to write the equations, look at your x's for how they're happening, and we can look at the y's to figure out our numbers. Okay, so these guys tend to be the things that throw wrenches at people. Don't randomly toss an x in over here for no reason. If y equals a number, it is a horizontal line. I had a surprising number of people on an equation from homework must have been 4, that it was like y equals 2, and just decided to do 2x for reasons. Don't add x's if there's not one there. Okay, what we're going to talk about today and what we're really going to focus on for, I think, the rest of this chapter are going to be absolute values. We've worked with absolute values before, but not a super ton. Probably touched on these in Algebra 1. So all of this is in the workbook on page 7. And this is going to be a piece that we see frequently. This is called our general form of our absolute values. And this is going to be the very first time we see 3 letters that we are going to see a billion times in this class. And I am not exaggerating. Because we are going to use, from now until May, A and H and K repeatedly. And they always, always, always have the same jobs. So we're going to start kind of figuring out what those jobs are and what they do. The very first thing we're going to look at is at a very important point that's going to help us in so many graphs that we do this year. And that's going to be our vertex. So the vertex is going to be the center point of an absolute value. So absolute values are kind of shaped like V's, absolute value, V-shaped. So it's the little point at the bottom. It's in the very center. If we think about the curved ones, whether it's right side up or upside down, it has a vertex here or here. If we have these guys, we have a vertex here, or we can go this way and have a vertex here. It's going to be that middle point. It's exactly where, getting back to our symmetry, it would fold to reflect across. Or I could flip it across. And the point where they line up. And where we're going to find that is if we look at these equations and we compare it to this piece, we're going to find H inside our absolute values here. H will always be inside the expression. And H tells us the x value of that point. The number plussed on the end, add at the very end, K, that guy's the y value. So inside here, this piece and this piece tell us where to start. One thing for us to note, and super duper important, this says x minus h. So h is always going to have the opposite sign that we see in here. So if this says plus, h is negative. If this says minus, h is positive. We're going to practice that a bunch. So just be careful because that's what this last blank is saying. It's the h value is the opposite of the value in the equation inside the absolute value. So the first thing we're going to do is practice identifying h and k because we're going to use that as our jumping off point for our graphs. Okay, so yours goes sideways, mine go vertical just because sideways made them very small. So what we're going to do is we are going to compare each of these equations to this is called our transformation form. We're going to try and figure out what h is, and we're going to figure out what k is. So I recommend, if we are not super comfortable spotting these, I rewrite that transformation form right here directly above it, because that makes it really easy to play match them up. Because I want to know what h is. We're going to see if we can figure out what h equals. And I want to know what k equals. So on this very, very first one, what number is being subtracted from x inside the absolute values? Or what's being subtracted from x? Is something being subtracted from x? No, nothing is being subtracted from x, right? What's a math word for nothing? 0. this is the exact same thing as if I wrote x minus 0. It means the exact same thing. So my h value is actually going to be, ooh, pen, 0. What number do we have added on the end of this one? I heard it was quiet. I'm adding nothing. I've got nothing here. Plus 0. So this one's going to have a starting point at the point 0, comma 0. That's where our vertex is going to be. That one's actually going to be called our parent function. We're going to look at that one several times, like the whole thing. Okay, now let's start looking at them when they've got some weird numbers going on. So let's look at B. And again, I'm just going to kind of rewrite this transformation form right here so we can play match them up. X minus h plus k. So what is h going to be equal to? Super close. Positive 3. Because my x's match up, so ignore them. The minus signs match up. So we have our positive 3 here. It's always going to have the opposite sign of this expression. So this is a minus, means this guy's going to be a plus. And that will remain true for literally every time we use h. It's always going to have the opposite sign of its expression. So our h here is going to be a positive 3. What's our k? Two. Let's say our h came from here, our k from here. So it's a positive 2. Like one thing that, a kind of a silly phrase that can help remember that sometimes is our h is a opposite. So it uses the opposite sign. Opposite. Or hop it is the opposite. I have absolutely no shame doing something ridiculous if it helps you remember something. Just wait till we get to asymptotes. Just saying. I just say he's having it for. I am fully willing to do complete ridiculousness if it helps you guys remember something. Oh yeah. All right. So now I'm going to try doing it without writing the full equation underneath it. Let's see what we can come up with. What's our h value on this one? Yes, negative 4. I heard it. Right there. Always the opposite. You don't have to put the equation there. I was going to try and do it without it. Because I know a lot of us are going to go, I don't have to write that every time. You don't have to. How about our k? What's our k here? Oh, as a point. That's what you mean. I'm paying attention. It's okay. Negative 7. Yeah, I forgot to write it as a point. I got excited. So our part B had the point 3, 2. And part C has the point negative 4, negative 7. It's always going to be h, then k. And that's right, it's in alphabetical order. Just like x, then y, h, then k. Alphabetical order. We're going to do one more like this, and then we'll see why the heck we care. What is our h value on this one?
5.
Positive 5. Good. What is our k value on this one? 0. Good. Because this is going to give us kind of a shortcut to figuring out where to start on our tables as opposed to just blindly guessing until we find the vertex. This tells us exactly where to start when it comes to graphing, and we have to do the least amount of work. We like to do the least amount of work. I know that. 100% valid. This gives us a shortcut for how to do that. Because what we're going to do is we're going to look at the bottom of that same page, page 8. When we're graphing an absolute value function, and this is just above the picture, the vertex is going to be written in the center of the table. Maybe another color. So what I mean by center, we've indicated with an arrow down here. The box with the arrow, that's where we're putting our vertex. It's going to be the middle. So if we look at this one, we have our y equals absolute value of x. What's our h for this one? What's our h on this one here? 0. And what's our k on this one? 0. There's nothing there. So our vertex on this guy is going to be at the point 0, comma, 0. So what we're going to do when we're making our table here to get our points is 0, 0 is going to go right in the middle. This is going to be our 0, 0. This is going to be where we put our vertex. That's why we want that. It tells us where the middle is on our table. Then we're going to pick x's to find y's so that we can get some points, right? So we need some x's that are bigger than bigger than 0. We need some x's that are smaller than 0. What are some x's that are bigger than 0? 1, 2, 3. We can get some x's that are smaller than 0. -1, -2, -3. You don't have to use those options. You don't have to go that far. A couple of points is usually enough to see it. Then we need to figure out our y values. And that does require us to remember a little bit more about absolute values than we've talked about yet so far today. Because what is the absolute value of 1? 1. What is the absolute value of -1? 1. Because what is the absolute value? How far it is from 0. It's how many steps away. It's an Apple Watch. It does not matter if I take one step this way or if I take one step that way. Still counts as one step. So absolute value is how many steps. So how many steps from 0 is 2? How many steps from 0 is -2? 2. So we're going to have our 2 here, and we're going to have a 2 here. How many steps from 0 is -3? How many steps? 3. How many steps from 0 is +3? 3. When in doubt, think about it literally as steps. If I come here and I went, okay, that's right. 1, 2, 3 steps. That's right there. 1, 2, 3 steps. There, right there. This gives us our points to plot up. So we're going to take our -3, +3. We're going to have our -2, +2. Our -1, +1. And then we've got our super special vertex at 0, 0. Ooh, that is the same color. Even though they look very different on my screen. Slightly different. Then we get our 1, 1, our 2, 2, and our 3, 3. And we can start to see this shape coming through. This is made up of 2 separate lines that just connect together. So when I connect these up, we're going to wind up with one line going this way. And it's going to have an arrow on it. And we're going to have one line going that way. And it's also going to get an arrow. So absolute values should be V-shaped. It is not a curve. It is a straight line. This is made up of 2 separate straight lines. I could make this if I had my 2. Here it is. Each of these is from a ruler. Use a ruler. Do not freehand lines. If you are doing it not here, get a Post-it note, edge of a notebook, edge of your phone for all I care. Use something. We're really bad at freehanding lines. Okay, So this is our first absolute value. Questions on this one? Okay, let's do one more, and then we'll work more with them tomorrow. So this is on page 9. It's slightly different. We might need a little bit of space to work, but for the most part, it's very, very similar. So we have our equation that says y equals minus x. Yours says y, mine says f of x. So I'm going to change mine real quick. They mean the same thing, but I just like to match you guys. So first thing we need to figure out is what's our vertex? Where am I going to start? I'm going to say what's my h and what's my k? 0 and 0. So it has the exact same vertex as the last one. Huh. So my h is 0 and my k is 0. So again, I'm going to need some x's that are bigger than 0 and some that are smaller than 0. I'm going to use those same ones. I'm going to pick 1, 2, and 3, -1, -2, and -3. If you flip these and put your positive numbers on the top and the negatives on the bottom, that is totally okay. I just tend to think smallest to largest and I work from top to bottom, but that's the way my brain likes to go. If you want to put -3, -2, -1, 0, 1, 2, 3, totally valid. It's a table. It's a tool. Fill it in however works for you. So then we need to be really careful. Because when we're thinking about our values that we're taking the absolute value of, we're going to take our negative absolute value of -3. Order of operations says I deal with this before I deal with the negative. So ignoring this piece, what is the absolute value of -3? 3. So we're going to bring this down. The answer for this part is 3. This becomes -3. So the opposite of the absolute value of 3 is -3. I'm gonna jump down and do the positive 3 because I feel like doing those two together makes way more sense than this. If we think about this one, this was this guy. If I do my absolute value of +3 that we've substituted here. So we have the opposite of the absolute value of +3. Again, I'm going to do this without this first. What is the absolute value of +3? What is this part? How many steps from 0 is 3? 3. But we need to bring this minus sign down too, because this is just the absolute value of 3. Just this guy. So this minus sign is still hanging out front. So this one is also a -3, because this minus sign is still hanging out here. Absolute values happen in our order of operations at the exact same time as parentheses. So we have to deal with our parentheses first, and then we can take the opposite sign. Then we can do the negative. Or we can think of it as -1 times whatever this is. So if we do the same thing with our -2, so again, I'm going to take my original expressions. We have our opposite of our absolute value of -2. Absolute values work as parentheses, so we got to do this guy first. What is the absolute value of -2? +2. We still have the opposite of our +2. That's going to give us a -2. So what's going to be our opposite of the absolute value of +2? What's going to go here? -2. What's going to be our opposite of the absolute value of -1? -1. Starting to see the pattern here. What about for +1? Also -1. So let's plot up these points and see what the heck is happening here. When we plot up these points, we're going to have -3, -3. So now we're way down here. -2, -2. -1, -1. And 0, 0. Then +1, -1. +2, -2. And +3, -3. So what changed between this one and the one we just did? What is different about this graph than the one we did before? It's going down. And in fact, if I look at them back to back, I don't like this animation thing we're doing. There we go. Flip. They are exactly the same, except this one got flipped upside down. And as we start looking through these letters, we're going to find out that that is one of the jobs of the number in front of the absolute value here, is it can flip it upside down. Okay, we are going to continue working with absolute values tomorrow because we have not done any of the funky number stuff. So we're going to work with those. So 1,5 is, yes. Yeah, so I have 1,5. Do I have 1,6? I love that. Oh, that's so much fun. The composition is papers. I didn't have to get that. I will have homework 6 for you tomorrow, and therefore it won't be due until Tuesday because I did not make the copy of it. I will have homework 1/6 for you tomorrow because my copy's wandered off. So I don't have it for you. So I will get you that tomorrow. Just because I don't have it right now.